Hi, I'm Rich with insideHPC, and we're here at SC13 in Denver, Colorado, and we're here at the AMD booth. We have a very special guest, Donour from, you're working with a NASCAR racing team, correct?
I am. I'm the trackside system director for Michael Waltrip Racing.
Okay.
We're based in Charlotte, North Carolina.
All right. And you guys use HPC to do the car design, don't you?
We do. It's as simple as this. Physical testing, wind tunnel testing, is very expensive for two reasons. Wind tunnels use a lot of power. They use a megawatt. They cost $1.25 a second to run. And you actually have to build the thing you want to test. So if you can take the design of the car, the model of the car, and test it in a computer, you can do it more cheaply and more quickly.
Okay, so you do a CFD simulation of the design, and then you use the AMD processors to crunch those numbers?
Yeah, we use essentially a very large version of what you have at home. A cluster of PCs using AMD processors to simulate the airflow over the car, using a solver for complex mathematical equations.
So give me a sense of how a small change can make a difference in an outcome of a race. I mean, does it really matter?
It's a big difference, and it comes down to the physics. If you go back to your freshman high school physics class, you'll remember that the pressure, the air pressure from a moving object goes up with the cube of the speed. So the faster you move, the more the air pressure makes a difference. And we're going 200 miles an hour on the racetrack every weekend. So small differences in the shape of the body change how much drag, how fast we can go.
Yeah, and these cars are kind of designed to look kind of like a street car, but with slight modifications that make a big difference?
They're designed to look as close to a street car as possible with a few small changes to improve safety. For example, they have a small little fin on the side that keeps them from rolling over when they go sideways.
Okay, so you're doing finite element stuff as well for the safety and the structures?
We also do finite element analysis for the structure of the car to ensure that the components are safe and won't fail during a race. However, that's a less intensive project than the aerodynamics of the car.
So help me out here. When you guys build a car, are you starting with a production model, or are you starting from scratch?
We start from scratch. We start from ideas in the engineer's head. Okay. So we have a dedicated team of design engineers who think of what the car should look like, think of a new way to build the parts, the components more efficiently and more performant. Then they'll design the part, draw it in the computer with the CAD software. We'll take it from CAD to structural analysis and then to aero analysis before we build it.
Okay. In that kind of workload, where are the bottlenecks right today? What would you say?
Well, for us, one of the biggest bottlenecks is the speed of the processor. So we use the fastest ones that we can find. As you see today, we're using AMD because they provide the most floating point throughput. And it's a very specific applications. Different applications have different requirements. For us, it's how fast can you multiply and divide numbers.
Okay. And for the applications you're using, what kind of scale are we talking? Are you able to use hundreds or thousands of cores at once, or what's the average, would you say?
Well, we're more than hundreds.
Yeah.
But as you might imagine, as we get into the details of how we design, it gets very secretive. So the more detail I give, the bigger the target is on our back. And so we've been very successful the past 2 seasons. The more successful we get, the less we can talk about.
Okay, I got you, Donour. So this is one of the biggest sports in America. What kind of money is involved? Like, if you can build the faster car or the one that does the job best, I mean, what's at stake here?
A lot of people are floored by the size of the industry. We're about a $4 billion industry every year. A large, serious team will spend $50 to $100 million a year designing, building, and testing their cars.
And how many cars might they build with that money? 4 or 5?
30 to 40.
30 to 40. Wow.
So we have 38 races per season. It's the longest season in professional sports.
So what's coming around the pike? If you had to use your crystal ball, I mean, sure, processors are going to get faster, but for your science, what do you see as what's going to get better?
For us, electronics are getting so cheap and so reliable that we're able to put more of them on the race car, have more instrumentation, more data, more telemetry, and make better engineering decisions week in and week out. Our turnaround time is probably as aggressive as any industry you'll see. Our time from design idea to delivery is less than a week.